Hello everyone and welcome to the session of design of cantilever retaining wall. So in this session we will learn the some theory as well as the design steps for the cantilever retaining wall as well as the failure occurs in the retaining wall. Here you can see the retaining wall, which is the first type, which is known as cantilever retaining wall. There is also the counterfort retaining wall. So in this session we will learn the about the cantilever retaining wall. Generally, the cantilever retaining wall is used to retain the soil as well as to maintain the ground profile at different elevation. So let us move ahead and see the what are the conditions as well as what is the purpose of the retaining wall. So here you can see in the figure number 1, which is the reinforced concrete retaining wall, we can say, which is generally used to retain the soil pressure. So which the soil is retained, or we can say the vertical slab. Here you can see this is the vertical slab. So this vertical slab is known as the stem. So this is the main vertical portion which retains the soil pressure. And here at the bottom, this is known as the bottom slab in the figure number 1. So this bottom slab is separated into the two sections. First, this portion, which is the bigger slab at the left hand side of the stem, this portion is known as the hill, and this portion is known as toe, and the back portion, which is the small portion, it is known as the hill. So generally the retaining wall are economical when the height of the wall is up to 8 meters, or we can say less than 8 meters, when we have to retain the soil up to 8 meter of the height. So generally the cantilever retaining wall, or we can say the counterfort retaining wall, are generally used when the ground elevations between the backfill and the other side at the are in the different elevations, or we can say at the different heights, as well as the backfill which is to be retained by the retaining wall is at the incline, or we can say at the some angle which is known as angle of friction or angle of repose. So this is the main purpose of the cantilever retaining wall. So as you here we will see the different components. So in the figure 2 you can see the type 1, which is cantilever retaining wall, as well as in the figure number 3. So here, as I told, this portion which is known as the vertical portion, which is the stem, which retains the, or we can say which retains or retains the soil pressure on the backfill side. Next, this portion is the bottom slab is divided into the two parts. The first part is the hill and second part is the toe. So and this is the backfill of the retaining wall. So before constructing, or we can say generally there are precast, we can say component wise retaining wall. So to lay this retaining wall, as in the figure number 3, this soil is to be prepared, and which is to be tamped, and the density it should be achieved to place this retaining wall in this kind of situations. So as there is also the shear key at the bottom, you can see over here. So generally the shear key are provided to avoid the failure due to sliding. If there is more pressure coming from the we can say there is more pressure of the soil or backfill, there is a chance of the failure due to sliding, and retaining wall gets failed. To avoid that failure due to sliding, we need to provide the shear key at the base, which will avoid the failure, or we can say sliding of that retaining wall. So let us move ahead. So here you will see the different failures of the cantilever retaining wall. So in the figure number 4 you can see this is the failure due to sliding, as here this is the portion of the soil, or we can say backfill, and due to backfill this pressure will be act on this face, which will try to move, or we can say which will try to force the retaining wall in this in the left side of the direction. So to avoid this, you can see this kind of shear key is provided, and the failure will be something sliding failure. Here you can see the effect, something like this, it will try to move ahead. So this kind of failure is known as sliding failure, and to avoid this we have to provide the shear key. In the figure number 1 you can see this is the overturning failure which will occur in the which will try to move the retaining wall in the anti-clockwise direction from the side of the backfill. So to avoid this we have to design heel, as well as we will design the heel portion and the toe portion to avoid this overturning of the failure of retaining wall. So generally there are three kinds of failure, or we can say there are two kinds of failure, such as sliding failure, overturning failure, and we have to check for the maximum earth pressure and the minimum earth pressure which is to be act on this retaining wall. So here the design problem is provided that design a cantilever retaining wall to retain earth embankment 4 meter above the ground level. Density of soil is 18 kN per meter cube, and angle of repose, which is also known as the angle of friction, is 30 degree. The embankment is horizontal at top, and SBC, which is soil bearing capacity, is 200 kN per meter square. The coefficient of friction between soil and footing is 0.5. Assume M20 as a grade of concrete and Fe415 as a grade of steel. So here all the data are provided to us, and the embankment is horizontal embankment. So coming on to the design procedure, there are generally 6 steps as per my convenience. So the step number 1, or the initial step for the design of the retaining wall, is the dimension. First we have to fix the dimension of the wall. So the dimension contains, we will see what are the different kinds of dimensions of retaining wall in our further slides. The second step is the we will check for the stability. So now stability check includes overturning check, sliding check, as well as the earth pressure check. Third, what we will do, we will design for the stem. Fourth, we will design for the toe, and we will design for the heel. Now, and finally we will have the figure. Now coming on to the dimensions. So figure number, as you can see the figure number 7, we will see the dimension such as this. You can see the height, which is the height of the ground, or we can say difference in the elevation. This is the DF, which is the depth of the footing, HS, which is the height of the stem, and here you can say overall height, which is the height of the elevation, or you can say difference in the elevation plus the depth of the footing. Here you can say thickness of the base, this is thickness of the stem, this is the XH distance from the face of this stem, and this is the XT, and the addition of XH and XT is the base, or we can say this is the base distance, and there will be the self weight acting due to the all these components. Thank you.